After reading the problem, it looks like we're looking for volume of a box, and they tell us that we have both length and width 2 feet less than the height of the box. So I've made a sketch here. If the height was x, then the length and the width would both be x minus 2. And so for any three-dimensional shape, volume would be equal to length times width times height. And in our case, that's just x minus 2 times x minus 2 times x. And if we were to multiply this all out, we would have x squared minus 4x plus 4 times x, or x cubed minus 4x squared plus 4x. So this is part A. Now find the dimensions of the box if the volume is 16 cubic feet. Well, now we're going to take that equation we have before, and we're going to set that equation equal to 16. We've just replaced volume with 16. Like any algebraic problem, we're going to set everything equal to 0 and hope we can factor. So we'll have x cubed minus 4x squared plus 4x minus 16 equal to 0. And here's a great application for factoring by grouping, because we've got two groups separated by an equal sign. Well, in our first group of two terms, an x squared is common, leaving x minus 4. And in our second term, a positive 4 appears to be common, leaving x minus 4. As normal, we are looking for a common factor. In this case, it's x minus 4. When we factor that out, what is left is x squared plus 4 equals 0. There's no more factoring that can be done here. We're all done because it's not the difference of two squares. And in this case, our 0 must be 4. So we've been asked for the dimensions of the box. Well, if x minus 4 equals 0, then x is 4. And that means both of these sides would be 2 and 2. And so if we check our volume, we're going to have length times width times height. 2 by 2 by 4 does in fact give us 16. So those are all the correct dimensions. 4 for a height, and each base is 2.